students, welcome to my channel. In this class, our topic is improper integrals, and we have to test the convergence of improper integral using Dirichlet test. What is this test and how we will apply this? If the function f of x is bounded, monotonic, and limit extending to infinity fx is equal to 0, then the integral a to infinity fx dx is convergent, provided absolute value of integration a to infinity gx dx is bounded as x takes all finite values. So here we have to test the convergence of a product of two functions here. The function fx that we choose must be bounded, second monotonic, and third limit extending to infinity f of x must be 0. It means the function should be bounded function. It must be monotonic, either increasing or decreasing, and limit extending to infinity fx should be 0. Then we can say integration a to infinity fx dx is convergent, provided the function g of x that we have chosen under integration sin a to infinity, taking absolute value, must be bounded as x takes all finite values. So let us solve a problem applying this Dirichlet test, by which the idea behind this test will be more clear to you. So the question is here, prove that integration 0 to infinity sin x by x to the power n dx n positive is convergent. So let us take here f of x is equal to 1 by x to the power n, and g of x is equal to sin x. Now let us consider the function first f of x. Here fx that we have chosen 1 by x to the power n is bounded and a monotonic decreasing. Here fx is equal to 1 by x to the power n is bounded, monotonic, decreasing, and limit x tends to infinity 1 by x to the power n is equal to 0. So the function f of x here satisfy all the essential conditions for the Dirichlet test. It is bounded function, monotonic decreasing, and limit extending to infinity 1 by x to the power n is equal to 0. Again, let us take the second function, that is g of x. Here we have taken g of x is sin x. Now integration a to x g of x dx mod. This is equals to integration a to x sin x dx absolute value, which is equals to minus cos x, because integration of sin x is minus cos x. Lower limit of the integration a, upper limit is x. This is minus outside cos x a to x. This is minus cos x minus cos a, which is equal to cos a minus cos x mod absolute value. This is less or equal to 2 for all finite values of x. This implies integration a to infinity sin x dx oscillates finitely. That is, it is bounded. So here, integration a to infinity sin x dx oscillates finitely, that is, it is bounded. Means the function g of x satisfy the condition of a Dirichlet test. Hence, the given integral 0 to infinity sin x by x to the power n dx is convergent by Dirichlet test. Proved. So, given integration a to infinity sin x by x to the power n x dx n greater than 0, we have taken fx is equal to 1 by x to the power n and g of x is equal to sin x. Now, the function f of x is bounded for n positive, monotonic decreasing and limit n tends to infinity 1 by x to the power n is equal to 0. Now we have started with the integration a to x gx dx absolute value, which is the absolute value of integration a to x sin x dx, and we get it less or equal to 2 for all finite values of x. It means integration a to infinity sin x dx oscillates finitely, that is, it is bounded. Hence, integration a to infinity sin x by x to the power n dx is convergent by a Dirichlet test. With this, the topic for today class is completed. I shall meet you with a new topic in my next class. Till then, goodbye.